Okay, uh, today we are going to see bit manipulation topic. First, we'll start with the introduction. Why it is necessary? We can use arithmetic operations like addition, subtraction, division, modulus, and everything. But only if you use bitwise operation, then only your computation speed will get increased when you use bitwise operations. So that's why we have to use bitwise operations. And next, we are going to see binary representation of numbers from 0 to 16. Binary representation from 0 to 16. I think most of you might know this trick, but I will tell this one. You start with 0 and 1 and 0, 1, 0, 1, 0, 1. Go like this. Zero, 1, 0, 1. And the next time when you are starting, you have to use two zeros. 0, 0, 1, 1. Again 0, 0, 1, 1. Just a minute. And again 0, 0, 1, 1. And the next time four zeros, four ones. And it will goes on. And next eight zeros, eight ones. And it will goes on up to eight ones. And this number is 0, and this is 1, 2, 3, 4, and 5, 1106, and 1117, and for 8, 8. I think we have to add another 16 zeros here. 1, 2, 3, 4, 5, 6, 7, 8, 9. I think I did one mistake. Just a minute. 1, 2, 3, 4, 5, 6, 7, 8. Okay, up to this 8, we have to use a 1 here. Okay, that's it. 8, 9, 10, 11, and 12, 13, 14, 15, 16. It goes on. The thing you have to remember here is the power of 2's. Here we started with 1, 0. So it is 2 power 0. 2 power 0 is 1. So we started with 1, 0. And the next column we used 2 power 1. 2 power 1 is 2. So we used 2 zeros. And next 2 power 2, 4 zeros. 2 power 3. 2 power 3 is 8. So we used 8 zeros and 8 ones. And 2 power 4 is 16. So we'll be using 16 zeros and 16 ones. Like this is the binary representation. And next we'll be seeing binary to decimal conversion and decimal to binary conversion. First, let's see decimal to binary conversion. We can take one example. Let's say 9. So we have to convert this in binary. Most of you know this technique. We'll be dividing it by 2, 4 times it's 8, and the remaining will be 1. And again divided by 2, 2 twos are 4, and the remaining is 0. And again divided by 2, 1 times 0, remaining is 0. So what you got, you just traverse in this direction and take the output 1, 0, 0, 1. You can cross check here. For our 9, the binary number is 1001. Okay. 1001. So how can we do this in code? For those who have attended the basic math section, they might know how to take a modulus of a number. So the same technique we are going to use here. See, we are every time we are reducing the number by n by 2, right? 9 is reduced to 4, how n by 2. Again, 4 is reduced to 2, how same n by 2. Again, 2 is reduced to 1, same n by 2. Each time when we are reducing, we are taking modulus operation and we are appending it to our result. That's it. So for storing our result, we need a string variable. String result initially we'll be keeping this as empty string, and then we have our number n is equal to, for say we can take 9, and I already discussed where to use while loop and for loop. If you know the limit, how many times the loop has to run, that time you have to use a for loop. If you doesn't know, you have only a specific condition. Here our condition is we have to reduce this number until 1 or 0. So we are having only condition. So that time you should use a while loop. What is our condition? N should be not equal to 0. Okay. I already told every time we have to reduce the number. Okay. In result, what we have to do? We have to append our answer. Result equal to, with our previous result, just add our n modulus 2. I hope everyone knows what n modulus will give you. And then finally, just print your result. That's it. You'll be getting 1001. Let's do a dry run of this code. Okay. We'll be doing a dry run. First iteration. Initially, we have n is equal to 9. And our result is empty initially. And first it will check the while loop condition. N is not equal to 0, which is 9 is not equal to 0. Okay, true. If it is true, it will get inside the while loop. Inside the while loop, first line is res equal to res plus n modulus 2. Okay, res is equal to, what is our initial res? It is empty. Okay, plus n modulus 2. Our n is 9. Initially, our n is 9. So if you take modulus of 2, which means just divide n by 2. What you will get? 8. Remainder. The remainder is n modulus 2. That's it. You're getting 1. So after appending this both, in result, 1 will be stored. Okay. And following, then n is equal to n by 2 will happen. So n is equal to 9 by 2, and n will be updated to 4. Right? And in the second iteration, it will separately maintain the n and result, so it won't be get confused. After our first iteration, 9 is updated to 4 and rest is updated to 1. Okay. Then in our second iteration, we have to check n is not equal to 0 or not. Yes, n is not equal to 0. Then what we have to do? We have to do rest is equal to rest plus n modulus of 2. Currently in our rest, we are having 1. Just append n modulus 2. What is n modulus 2? 4 modulus 2. 4 modulus will give you 0. So this is not a addition operation. This is concatenation operation because we are using string. So we'll be getting 1, 0. And next we have to reduce our n. So n will be n by 2, which is 4 by 2. 4 by 2 will result in 2. So just update your n as 2 and update your res as 1, 0. Next, coming to our third iteration, again we have to check n is not equal to 0. Yes, n is not equal to 0. Then rest is equal to rest plus n modulus 2. This time What is our S? 1, 0. Okay. N modulus 2. What is our N? 2. 2 modulus 2 will result in 0. Okay. Just append it. 1, 0, 0. Then coming to our just wait a minute. We have to update our S. This will be updated to 1, 0, 0. And also we have to update our N. N is equal to N by 2, which is 2 by 2. 2 by 2 will result in 1. Okay. Just update N, our N as 1. And our fourth iteration. Now, fourth iteration, again, we'll be checking n is not equal to 0. Yes, n is not equal to 0. So, res is equal to res plus n modulus 2. What is our res? 1, 0, 0. What is 1 modulus of 2? 1. Just concatenate it. 1, 0, 0, 1. You will be getting 1, 0, 0, 1. Next, what else you have to do? You have to update your n. N is equal to n by 2, which is 1 by 2. You will be resulting in 0. Just update it and your rest will be 0, 0, 1. Okay, next, moving to our fifth iteration, what will happen? We have to check our n. N is not equal to 0. No, it will get false. Then our looping statement will get ended and we will be printing our res. Okay, what is our res? 1, 0, 0, 1. Okay. Now we know how to convert a decimal number to binary.
Till that, we hope everyone can understand. And why we are focusing in bit manipulation in the starting stage means what is data structure? Data structure is mainly organize the data in a proper, efficient way. The efficient mean that we need optimized way. That is what actually bit will do, bit manipulation. Because computers actually whatever you written in the code, syntaxes, everything, computer will take zeros and ones bits only. So that bit manipulation will most efficient way to work with data inside the computer. That's why we are covering this bit manipulation in the starting itself. This is why bit manipulation is started. And this 0 to 16 representation, this representation is very easy. We are saw in the first semester itself, zeros, ones. Here we can understand this first means we will afterwards the upcoming problems, everything we will solve easily. Then till that decimal to binary, everyone will understood, right? Just to give a thumbs up or any doubts if you have means you will ask.
If you have any doubts, you can ask. Okay. Any doubts or we can move forward. Okay, we are getting few thumbs ups. Good. So please. Hmm. Next, we'll cover binary to decimal. So you take the same binary number 1001, which is 9, right? Just now we saw, which is 9. So before moving to the code, just do analysis how we are calculating a binary number, binary to decimal. This place I already told 2 power 0 and this is 2 power 1 and this is 2 power 2 and this is 2 power 3 is 8 and 2 power 2 is 4, 2 power 1 is 2 and 2 power 0 is 1. Just what you have to do, just do a multiplication operation between this 8 and 1 and between this 4 and 2, between this 2 and 0, between this 1 and 1. What you will be getting 1 into 8, 8. 0 into 4, 0. 0 into 2, 0. 1 into 1, 1. Once you got this result, just sum it up. 8 plus 0 plus 0 plus 1, you will be getting 9. This is the actual way you can convert a binary, any binary number to a decimal number. Simply, if this is confusing, 2 power 0, 2 power 1, 2 power 2, 2 power 3, this is confusing, you can just simply start with 1 and just 2, 2 twos are 4, 4 twos are 8, 8 twos are 16, 16 twos are 32. Like this also you can go. Both are same only. Let's the one thing you have to understand is if it is 0, then you don't have to consider this. Anyway, it will be ending up in 0 only. So you have to care only if it is 1. Only if it is 1, we have to do some multiplication operation, and then after we have to add that value in our result. Also, the one more thing to note here is for every iteration, you have to check this this power value is getting increased, like 2 power 1, 2 power 2, 2 power 8, 2 power 3, 2 power 4, like this, it increasing for every iteration. So for keeping that track, you need a power variable, and initially it will be 1. So here we are using initially 1, so I'm keeping it as 1. And for each and every iteration, it should be multiplied with 2, right? For first iteration, if the power is getting multiplied with 2, we'll be getting 2. For the next iteration, power into 2, 4. 4 power into 2, 8. Power into 2, 16. Likewise, we can get it. Just we have to multiply power equal to power into 2. That's it. So let's move to our code, decimal to binary. Same, we need a result variable here. So, okay. Initially, our result will be empty as usual. And then we are going to traverse a for loop. Here we know our condition. We are going to traverse only four times up to n. So we know our condition. So here we are going to use our for loop. I is equal to, and the one more important thing is just consider it as a string variable. Okay, this is not integer, this is a string variable. Okay. We are going to traverse from the end. So what we have to do? N dot length minus 1. So you'll be getting this index. Okay. Then I should be greater than or equal to 0 and I minus minus. Okay. After this is fine. Next, what you have to do? You have to check. I already told if it is 1 only, you have to consider this. If it is 0, just ignore it. Here at I is equal to 1 power, and we have to add. So here result. Oh, sorry. I, okay. Result equal to result plus power. I will explain this when we do a dry run. I will explain this part. It will be clear that time. Because 1 multiplied with anything, you will be getting anything only. 1 into 2 is 2 only. 1 into 3 will be 3 only. So why we have to doing a multiply operation? Instead, we can directly add the power value. That's it. Here also you can see 8 plus 1 we did. We don't have to multiply anything. We can directly add the power value. That's it. Also, if you are doing like this, then you have to make sure your rest should be the integer value, not a string value. That's it. Initially it will be 0. Okay, right. Okay, after this condition, we have to increment our power. I already told this one. So power is equal to power into 2. So every iteration, it will get multiplied by 2. That's it. Once the loop is completed, just print your result. You'll be getting your result. Just see a dry run of this one. Okay, dry run. First iteration. Also store our variables in a separate way. Power is initially 1 and result is initially 0. That's it. And what is our n? 1, 0, 0, 1. Okay, I will be initially in this place. Okay, now what we are to check whether our I is equal to 1. We have to check that, right? Check our I is equal to 1 or not. Yes, it is equal to 1. So if it is equal to 1, you have to do this equal to rest plus power. Okay, our rest is initially 0 and our power is initially 1. So you will be getting 1 and your result is updated to 1. Okay, right? Then what else? You have to update the power. Power is equal to power into 2. So our initial power is 1 and if you multiply it with 2, you'll be getting 2. Okay, for next iteration, it's updated to 2. That is what we wanted. You can check here. For next iteration, we need a 2 here. Okay, we got the 2 there. Let's move to our second iteration. Second iteration, I will get decremented in the for loop. Okay, I minus minus. Then we have to check whether our character at I is equal to 1. No, it is equal to 0. So our if condition won't get executed here. Only we have to update our power. Sorry, power. So our power will be power into 2. Now currently we have our power as 2. Then if you multiply it with 4, sorry, 2, you will be getting 4. That is what we needed for our next iteration. Here you can check. We need 4 in our next iteration. Okay, we got this. Then nothing else to do with this. We can move to our third iteration. Just make sure to update your power as 4. And in our third iteration, I will get decremented I minus minus. And then we have to check again whether our I is equal to 1 or not. No, it is not equal to 1. So we'll be only updating our power. So power is equal to power into 2. Currently our power is 4. So 4 into 2, it is 8. Okay. That is what we needed for our next iteration. Power. Okay, we got this one. Moving to our fourth iteration, just update your power as 8. Moving to our fourth iteration, which is I minus minus will happen at first. So I will be moving here and you have to check the if condition whether the current character at I is equal to 1 or not. Yes, if it is equal to 1, what we have to do? We have to update our rest. Rest equal to rest plus power. What is our rest? 1. What is our power? 8. Add both of this, you will be getting 9. That's it. Go and update your rest as 9. And after this, in every iteration, we need to update our power. Power is equal to power into 2, which is 16. It's getting ready for the next iteration. But the fifth iteration, what will happen? When we do a I minus minus, it will go to the minus 1th index. Here we have our condition as I should be greater than or equal to 0. So that's it. It will get end here. And finally, we are printing our result. What is stored in our result? 9. So for this input, you will be getting 9 as our output. Fine. That's it. Binary to decimal conversion. If you have any doubts, you can ask here. Otherwise, just give a thumbs up. Any doubts, you can ask. Okay, no thumbs up. Okay. Mm, okay. Okay. Next, move to our next topic. Now we are going to cover our basic things, which is truth table. Okay. And or XOR not. Okay, these operations we are going to cover. Let's take 0, 0, 0, 1, 1, 0, and 1, 1. For simple sake, consider AND as a multiplication operation and OR as an addition operation. It will be easy for you to find out the output. So this will be the input, this will be the output. 0 into 0 will be getting 0, 0 into 1 will be getting again 0, 1 into 0, 0, 1 into 1, 1. And same for OR operation. Our input output 0, 0, 0, 1, 1, 0, 1, 1. Just add both of them 0, 1, 1. 1 plus 1 will be getting 2, but in binary number we'll be having only zeros and ones. So just remember this, we have to put 1 here as 2 is not there. Okay, next 0, 0, 0, 1, 1, 0, 1, 1. For XOR, you have to remember if both the inputs are same, you have to put 0, or else you have to put 1. Same, not same. Okay, these both are same, so 0. Different, 1. Different, 1. Same, 0. That's it. And for NOT operation, if it is 0, it will be converted to 1. If it is 1, it will be converted to 0. That's it. But few patterns you have to know here. For example, in AND gate, if you are doing AND with 0, any number, if you are doing AND with 0, the result will be 0 only. Also, you are taking 1 and you are doing some AND operations with 1, the result will be the some number only. Uh, you can take the 1 into 2, 1 into 3, that example, 1 into 4, you'll be getting 2, 3, 4 only. Likewise, if you take any binary number and if you do an AND operation with 1, you'll be getting that any binary number only. If you are doing with 0, the result will be 0 only, because 0 into any number, it will be 0 only. And for OR operation, you have to remember, if you got any input, any two of the inputs is 1, then the result will be 1 only. Regarding the next number, it will throw 1 only, because we are adding no. So 1 plus any number 0 or 1, you will be getting 1. So this thing you have to remember in OR operation. And XOR, I already told, same means 1, different means 0. Sorry, same means 0, different means 1. That's it. And one more thing you have to remember in the AND operation, if you are doing XOR operation, if you are taking same numbers 5 XOR 5, it will result in 0 only. This XOR will act as addition as well as subtraction in some cases. For example, if you take 6, we can take 4, sorry, 5 and 4. This is 5 and this is 4. If you do a XOR, just check the result. Different. So different means 1. Same. So same means 0. Same. Same means 0. What is this? Convert this to decimal. We'll be getting 1. So 5 minus 4, what is the result? 1. Okay. If you want to make this to perform addition operation, you can take this example. You can take 4 and 3. 3 is 0, 1, 1. So this is 4 and this is 3. You are doing a XOR operation. Different. Okay. 1. Different. Okay. 1. Different. Okay. 1. If you convert this to decimal, you will be getting 7. You can check this one. 2 power 0, 2 power 1, 2 power 2. So 4 plus 2 plus 1 is 7. Okay, we got 7 here. And 4 plus 3, it will give 7. So the thing you have to note here is XOR will sometimes act as plus and sometimes it will act as a subtraction operation. So this thing you have to remember. We'll be using this in upcoming sums. Okay, next we'll cover patterns. Patterns. Same only and or XOR, NOT, and shifting. Oh, sorry, I forgot to teach shifting. To cover here itself. In shifting, you will be having left shift and as well as right shift. Only you have to remember few things here. If you are doing a left shift by two times, any number you take. For example, I will take 1. So not 1, we'll take some big number 5. Okay. 5 in binary will write this as 101. If you are doing this 101 left shift two times, initially two zeros will be added. And this 1 will be shifted here, and this 0 will be shifted here, and this 1 will be shifted here. You will be ending up with this number. And also, same right shift you are doing for the same 5, what will happen? The first two numbers will get discarded. The remaining will be your output for your right shift. Just remember this, the first two numbers will get discarded and the rest of the numbers will be your output. That's it. And the one more pattern is n minus 1 pattern. We'll be discussing these patterns with example problems. If you can able to understand all these problems, all these patterns, then 80% of the bit manipulation problems you can able to solve. Mm, Directly move to our problems. The first sum will be covering starting two numbers. This is one of the important interview question. So we'll be having 6, B will be having 5. The interviewer will ask you to shift the output, shift to swap two numbers. The output should look like A is equal to 6, sorry, B is equal to 6 and A is equal to 5. Initially, A is having 6, so now it's having B's value. And initially, B is having 5, and now finally it's having A's value. So we can do this in a lot of ways. First, I will explain with normal technique. So how can we swap two numbers? Let's let's take our example 5 and 6. Or else we can take a big number 14 and 8. We can take 14 and 8. Just check the difference. We are having difference as 6, right? If I add our 6 to this 8, we'll be getting 14. And if I subtract the same 6 to this 14, we'll be getting 8. Okay, now you can say this 14 is converted to 8 and this 8 is converted to 14. Just we are taking the difference and we are doing addition and subtraction operation. That's it. This is one way of doing. And the another way will be addition way. We'll be doing 5 plus 6. 5 plus 6 will be 11. And if you take this 11 and minus 6, you'll be getting 5. And again take the same 11, do minus 5, you'll be getting 6. With 6, you are getting 5. With 5, you are getting 6. That's it. You can also do this in this way. Let's have the code and do a try run. It will be more clear. First, what I did, A is equal to A plus B. Yeah, wait. Before that, one more easy way is there. I will explain that. You can use a extra variable like C in C. And what are current variables? A is equal to 6, and B is equal to 5, and C is equal to initially 0. Okay. With using this extra variable, we are storing our B value in C. So C will be containing 5. Okay. Even if the B is discarded, we don't need to care about this because already the B value is stored in some other variable, which is C, right? Even if you don't have this B, then don't worry. We have C. So we can modify this B directly. So we are storing this A value in B. So we'll be getting 6 here. Then what we need, we have to make the A as 5. B is already having 6 here. Okay. But we have to change this A to 5. For that, we need B value. We already stored the B value in C. Just use it. A is equal to C. That's it. These are the three steps you have to follow. But if you do this step, the interviewer will add a follow-up question like, don't use an extra variable, do that in two variable itself. Like that, they say. You can do our addition or subtraction operation. Here I'm doing addition operation. A is equal to A plus, first I will write our expected output. Expected output will be A is equal to 5 and B is equal to 6. Okay. And here we are having our memory. Initially A is having 6 and B is having 5. Okay. Now we are doing A is equal to A plus B, which is 6 plus 5 will get resulted in 11, and the 11 will be stored in A. Okay, now 11, A is modified to 11. Okay, right. Next, take the B. In B, what is the expected output? 6. What are the variables we are having? We are having we have 11 and 5. How we can get 6 here, which is if you add, you are getting 16. Okay. If you do a subtraction, you'll be getting 6. Okay, then we can do a subtraction, right? Just do it. A minus B, then in B, 6 will be stored, which is 11 minus 5, 6 is stored now. Okay, now in A you have 11 and in B you have 6. With the subtraction operation, you will be getting 5. So again do A is equal to A minus B, which is 11 minus the 6, will be getting 5. This 5 should be stored in A, so I'm storing it in A. That's it. This is another way of doing. Here we use the extra variable C, but here we didn't use any extra variable. Okay, but if the interviewer again asks you another follow-up, like don't use arithmetic operation, use only bitwise operation. Here comes our bitwise operation. I already told if you are doing some operations like addition and subtraction, what we have to use? XOR, right? I already discussed about this. Same you have to use here. But it will be a little confusing, but listen carefully. I will make it clear. Taking A XOR B. What is our A? 6. What is our B? 5. And our expected output is A is equal to 5 and B is equal to 6. This is expected output. Okay. And these are our current variable values. Current value. Okay. Currently in A, we are having 6 and in B, we are having 5. Okay. Then what you are doing? A XOR B. If you do A XOR B, what will be stored in A? 6 XOR 5, right? Don't worry about the output. Just remember 6 or 5. That's it. Then in B, we are having 6 or 5. And again, we are drawing it, which is 5. So this both will get cancelled and you will be ending up 6 and that 6 is stored in B. Right. Now update your B as 6. Now what is in our current value? Already you are having 6 or 5 and in B you are having 6. So now you already got 6. You need 5. Some operation you have to do between these two numbers so that you should end up with 5. So what you can do? Again do a XOR. You have 6 or 5 and you have a 6. Again 2 is R. This time 6 will get cancelled. Cancel means it will result in 0, and zeros are 5. It will give only 5 only. Okay. So the 5 should be stored in where A. Okay. Again do the same. A is equal to A is or B. That's it. So I'll be writing the code clearly below. A is equal to A is or B, and B is equal to A is or B, and again A is equal to A is or B. Simple code only, but the thing is you have to understand the logic. Just do a dry run, practice yourself, you'll be getting more clear. Try with some other examples. Take A is equal to 13 and B is equal to 7. Do the same and do a dry run and understand. It will be more clear. I hope this is clear. If you have any doubts, you can ask. Otherwise, we'll go to next one. Okay. Okay, we'll move to the next one.
Excuse me,
Any
sir.
doubts?
I
Hello.
think you stopped sharing your screen.
Stop sharing. Click my phone. From when it got stopped?
When you were explaining A is equal to 6 or 5.
Okay, okay. No problem. I will explain again. Okay, you having these two numbers, A is equal to 6 and B is equal to 5. What is our expected output? A should be 5 and B should be 6. Okay. What is our current values in A and B? Currently in A we have 6 and B we having 5. Okay. So we did addition and subtraction operation previously. Likewise, you have to use a XOR operation, A is or B, and we are storing it in A itself. You can store it in B also, that is fine, but here I'm using A. So your A is updated to A XOR B, which is 6 XOR 5. So 6 or 5 will be stored in A. Don't worry about the result. Just simply remember 6 or 5. That is enough. Once again. Okay. Next, what you have to do. Now you are in current variable, you are having 6 or 5 and a 5. So you have to do some operation and make this as either 6 or 5. So you are having 6 or 5 and 1 5. So you have to do some operation. Let's say I'm doing XOR operation. If I do a XOR operation, same numbers will get 0, right? So 6 or 0, you'll be getting 0. Sorry, you will be getting 6. Now you got 6. Where you have to store the 6? In B you have to store. So simply you can say B is equal to, you are storing A or B. A or B. What is A? Already we are storing A or B here in A. So it will result in 6 or 5, and in B we are having 5. So if you do XOR operation for 6, 5, 5, 5, 5 will get cancelled. It will result in 0, and zeros or any number is your output. So 6 will be stored in this B. So update your current variable B as 6. Now you are having 6 or 5 and you are having 6. You are having these two variables. You have to do some operation and make this as a 5. We already got 6. Only we need 5 now. So again do a XOR operation. Take this A 6 or B and your B is 6. And if you do XOR operation between both will get cancelled and you will be getting 5. Just store this 5 in A. That's it. A is equal to A XOR B. What is our A? 6 XOR 5. Here you can see. And what is our B? 6. If you do this, you'll be getting 5. That's it. The code, this is our code. A is equal to A XOR B, B is equal to A XOR B, and A is equal to A XOR B. That's it. Just you have to understand the logic, dry run, do some dry run with this example, then it will be more clear. Any doubts? Okay.
Just give a thumbs up if you don't have any doubt also means we can continue with next problem.
Okay.
Yeah, thank you.
Next, I think time is running up, so I will try to cover at least 3 problems or 2. Check if the ith bit is set or not. Okay. What is mean by set or not? If you are having some number, let's say I'm taking 9, 0, 0, 0, 1, and another number 13. For 13, 1, 1, 0, 1. Here, or I
Zero or one.
to what happened? Okay.
Nothing, bro. You just continue.
Okay, okay. Here also we are having our IS 2. In this case, you have to consider in a reverse index order 0, 1, 2, 3. So what is our ith bit for 13? This bit. And what is our ith bit for 9? This bit. So if it is set, only if the bit has 1, we can say it as set bit. If it is 0, then it is not a set bit. If it is a set bit, you have to return true, or else just return a false. That's it. So how can we do this? Just take this number and take this number. You have to check this bit. Again, you'll be doing some operation here, either and or not, or any operation you'll be doing with some number, then you'll be getting some result. Okay. Here we are having two possibilities. Either the ith bit may be 0 or it might be 1. So you have to check whether it is set or not. So that, for example, I'm using a 1 here and I'm doing a AND operation. First I'm checking with AND and next or next not. Sorry, not. Next I will check it with XOR. First AND. What is 0 and 1? It will give you 0. What is 1 and 1? It will give you 1. So from this you can understand, if you are dealing with 0 and if you are AND with 1, you will be getting 0. If you are dealing with 1 and you are AND with 1, you will be getting 1. So the result is 0, then you can surely tell it is not a set bit. If you got 1 here, then you can say it is a set bit. You can also try it with, we have two possibilities, or ith bit might be 0 or it may be 1. If you are doing an OR operation with 1, just check what is happening. 0 or 1 will be 1, which is false. We should not get 1 here because 1 or 1 also will be 1. So we can't differentiate whether it is a set bit or not. But if you use an AND operation, you can clearly differentiate. If you got a result as 0, it is not a set bit. If you got a result as 1, it is a set bit. So AND will be more suitable for this operation. But the thing is, you have to place the 1 here. How you can place the 1 here? We already discussed about left shifting. Just left shift 1 to I times, or I is 2 in this case. So if you left shift with 1, what you will be getting? Two zeros you have to add, and the 1 will be placed here. So you are getting 100. Just put it 100, and the leadings will be always 0. Again, here also 100, and the readings will be 0. Now we are going to do a AND operation here. 1, because the other things are 0, always you will be getting zeros only. Apart from this bit, other bits will be 0. Because 0 multiplied by anything, you will be getting 0 only. Only you have to check whether, so the output will be purely depends upon this bit only. If you got a 0 here, then everything will be 0. If you got not a 0, maybe 1, then you can say this is a set bit. Here you can conclude it is not a set bit. That's it. So the conclusion is, if you are ending up with 0, your result as 0, then you can surely say it is not a set bit. If your result is not equal to 0, then you can say it is a set bit. That's it. I think for now I will write the code. Okay. What we did, we just take the n and we did the AND operation with what? After left shifting 1 I times, we did the AND operation with n. This is our code. Okay. Just add if condition here. If this is equal to 0, then return a false because it is not a set bit. Else return true. Don't worry if it is not clear. We'll continue tomorrow. I think it's time. That's it for today. If you have any doubts, you can ask. Any doubts, you can ask.
Or else, if you have any documents, put in chat box also. We will respond for that.
Okay, if you guys don't have any doubts, we can wind up the session.
But whatever problems we cover daily, you can dry run it by yourself. Then only you can get the idea how to approach a problem, and you will remember the logics.
You should at least practice one problems every day. Will you provide recording of the class? Yes, it's the recorder will be providing the recording in Algo's group.
In group, we will share a drive link. There you can find all the recording sessions of our classes. With notes also, we are providing everything you will get by today about today. Any other doubts? Yeah, definitely we will post notes also there.
Anything else?
We are expecting more questions. Anyone have any questions? Okay.
Okay, guys, bye.
Okay, bro. Bye.
Okay, we will wind up our sessions. We will see you on tomorrow's session. Thank you for everyone for joining.